Everyone. In this video, I'll be talking about a visual representation of the material balance equation. So you see here, this is the general formula for the material balance equation. With some rearrangement, we get this format where we have one on the right hand side. So this format gives us a plot called the energy plot. Energy plot is talks about the drive mechanisms of the reservoir, such as water drive, depletion drive, and gas cap drive. So the reason that this plot is important is because we want to understand what drives our reservoir, which is it gas, is it oil, and so on and so forth. So I've been getting this question about not knowing which secondary recovery method to use. Is it gas or is it oil? Some students seem to be just choosing different scenarios with gas and oil, and until they get the best recovery, even though it works at the end, but it's not scientific and it's just waste of time. So if you know your major driver of your reservoir, then you just choose it instead of choosing all the different methods and seeing which one gives the best result. So the first one is the depletion drive index, which is about the soluble gas in the oil. So when your pressure drops below the bubble point, this gas liberates and expands, and it drives your oil. The second one is your gas cap. The third one is your drive index. And the fourth one is the which is usually neglected, is the rock expansion. So these four equal 1. So for example, if our water drive index is, let's say, 0.7, it means that water drive is the biggest contributor to our drive mechanism. So we can just go for water injection instead of experimenting with gas injection. So this maybe complex formula can be represented in another way, which is this. So here I'm using a MBAL software, and you can see this is from 0 to 1, which is the same as this. So here I'm producing from 95 to 2004, and you can see the pink one is the water influx, and the blue one is the fluid expansion, which is the depletion drive index. So at the beginning of the production, as you produce, your pressure drops and your fluid expands and it drives your reservoir. Then your aquifer start playing bigger role and starts invading your oil zone more, which leads to some pressure increase, and thus the fluid expansion becomes less important than water influx until the end. So here we don't have a gas cap, so in this case it's better for us if we just invest in water injection. Here is another example where we have the pink one is the water influx and the red one is the gas cap expansion. So you see from 1981 until around 1985, our water influx is much higher than our gas cap expansion. So here the yellow is water injection, not gas injection, because water, if you change your water uh, parameter, which is around 45%, is much higher than, let's say this is like 10%. So if you change your water, it affects your reservoir more than if you play around with your gas cap expansion. So here we see we inject water, and we see that as we start injecting water, the water drive is around 75% contributor to our drive mechanism. So the data that you need to get the energy plot is simple reservoir data, like temperature, pressure, porosity. Most of these data you get from Petrel after you create your model. Like I said before, raw compressibility and compaction is not that big of a contributor. If you have a production history, that would help a lot, because if you don't have your water influx data, for this example I'm using a radial aquifer, if you don't have these data, you can get it from the production history. So I'll show you now. You see here that the red one is the black dots are our history data. The red one is a simulation without aquifer influx, and the blue one is a simulation with aquifer influx. So since the blue is matching the red, the black points, it means our aquifer data is correct. So I'm just going to demonstrate that if you have a production history, you can get some of the data, even though if you don't have all of it. So I'm going to change the aquifer permeability into, let's say, 19 millidarcy. So you see now the blue one, which has aquifer, is not matching our history data, so this is wrong. So all we need to do is regression, and we take aquifer permeability and we calculate. So the computer calculates for us and suggests that aquifer permeability is 197 millidarcy, and you see that now the aquifer is correct, and it gives us a correct energy plot. So this is just to demonstrate that it is even though if you don't have all the data, it's fine, you can get it from the production history. I hope that now you when it comes to choosing your secondary production, whether it was gas or water, it's more based off some study, some scientific study, instead of just trial and error. So this will save you a lot of time. Thank you.